Hi, my name is John. This is part two of the review for Mr. Scott, chapter six, exam. We're going to be trying to figure out how to use the law of cosines, to use the law of sines, as well as finding the area of a triangle using any of the area formulas. Before we do that, we're going to do one question first. If I have 28 degrees, 17 minutes, 51 seconds, and then we subtract 13 degrees, 54 minutes, and 57 seconds. How do I do something like this? Well, let's do this out really quickly because I didn't do a problem like this on the exam. 28 degrees, 17 minutes, 51 seconds, and subtract 13 degrees, 54 minutes, and 57 seconds. Well, the first thing I'm going to do is I'm going to start with the seconds and go 51 minus 57. You can't really do that because you'll end up with a negative number. So what we do is we're going to borrow 1 degree here. This becomes 16 degrees. And we add 60 seconds to it. 1 degree is 60 seconds. Oh, remember how you borrow and add? Third grade using subtraction. So 60 plus 51 is 111 minus 57. And you end up with 54. 54 plus 57 is 111, so 54 seconds. 16 minus 50, 16 minutes again, minus 54. We can't do that either. 16 minus 54. Oh, that should have been a minute, by the way. So you have to borrow one here. It becomes 27 degrees. Add 60. Remember, 60 minutes is 1 second, so it's going to be 76 minus 54. It's going to be 22 minutes. 22 minutes right there. And then 27 minus 13 is 14 degrees. And there it is. Okay, make sure you know how to do this. It probably will be on the exam. Let's try another problem right over here. We're going to do the law of sines last because it creates the ambiguous case. We're going to do the law of cosines first, okay? Remember the law of cosine. You can use the SAS situation or the SSS situation. Let's create an SSS situation where you have A1, A is equal to 5, B is equal to 12, and C is equal to 13. Well, let's see what happens now at this stage. We're going to just draw it out really quickly. Since this is the longest length, I'm going to set this C equals 13. That must be the big angle right there. The shortest length is 5. That's A equals 5. And this is going to be big A. And big B and little b is going to be 12. You could have used any formula you wanted. Let's just go a squared is equal to b squared plus c squared minus 2ab times the cosine of big A. That's one of your formulas. You input A is 5, 25 is equal to b squared, which is 12 squared, 144, plus c squared is 169 minus 2 times 12 times 13 times cosine of A right there. 144 plus 169 is 313. It's equal to 25 minus, I don't know what 24 times 13 is. So let's go 24 times 13. You end up with 312. 312 times cosine of big A. How do I solve this out? First of all, I have to get rid of this 313 first. That gets rid of that. How do I get rid of this negative 312? I divide it by negative 312. That gets rid of that. How do I take the cosine out of the angle? You take the cosine inverse. That gets rid of that. That's equal to your angle. So it's going to be, I got here 25 minus 313 equals, and then divided by negative 312. And then I take the cosine inverse of the answer. I use the answer key right here. It helps me. I don't have to type it in again. I end up with 22.6 degrees. Approximately 22.6 degrees. Once you find out what your angle is, You can figure out other angles by using the law of sines now. The law of sines is a lot easier to use, by the way, just to let you know. So, by the way, just to confirm, I did this very special because this right here is 5, 12, 13 is a right triangle. I know that this makes a right angle right over there. If this is 22.6, 90 minus that, 90 minus my answer is 67.4 degrees. Approximately, because these are complementary. Got it? So that's the 90-degree angle. These have to add up to 90. Or I could have used law of sines, because if I didn't know this was 90, I have to use sine of A over A equals sine of B over B. Okay? I'm going to do the law of sines next, and then we'll go on from there. Okay? So how do we use the law of sines? Let's try a triangle out. Law of sines. Let's say, for instance, you have an ASS situation. That's a really bad word, so you're going to have the ambiguous case. The angle is equal to, let's say, 120 degrees. And side 1 is equal to 5. I'm sorry, let's say angle A, angle C. And little c is equal to 5, and little b is equal to 20. So it's going to look something like this, just to show you. 120 degrees is about here. That's C right there. And then this is B, is equal to 20. And making sure that it's kind of no figure drawn to scale. If this length is 20, then this length is probably about 5 right there. And there it is right there. Well, it's a little bit bigger, but it can't really hit it. So there's actually no triangle that makes it. Well, suppose that we can draw a triangle. So that's B equals 20, C equals 5, and big C equals 120 degrees, right? Well, we should tell me what big B is then. Using the law of sines, sine of B over little b, which is 20, is equal to sine of 120 over little c, which is 5. And then to get rid of that 20, I'm going to multiply by 20 right here. And cancel those out, get 1 and 4, so it's going to be 4 times sine of 20. 4 times sine of 20, 120 degrees, is going to give you 3.46. And there it is right there, 3.46. So, sine of b is equal to 3.46. How to get rid of the sine? You take the sine inverse. So if I take the sine inverse, can you see that pretty well? Okay, of the answer. I end up with domain error because you can't make out the triangle right here. So just by using the law of sines, if you don't get a triangle, means that there's therefore no triangle is made. And there it is. And the reason for that is this value has to be between -1 and 1, because that's where the domain is. The domain is between -1 and 1. And if it's greater than 1 or less than -1, that means you got a problem. Okay, and we know that there's going to be no triangle for this. But let's try one triangle that does make sense, a little bit easier to work with. Let's try this one right over here. An ASS situation where the angle C is equal to 130 degrees, and B is equal to, let's say 20, and little c is equal to 5 now. No, let's not try 5. Let's try like 10. Okay. So we draw the base right here. The angle is 30 degrees. Try to draw it right. This is about 30 degrees, somewhere around there, right? This distance is B. It's 20, and this right here, from here to here, is 20. Sorry, 10. Let's make it, instead of 20, let's make it a little bit bigger, like 18. That way I know it's going to work. 18 here. That means this is going to be 18. And it's going to hit it right here as well. It's going to be 18. So the two triangles that you see is this one right over here. There's your first triangle. There it is, because it hits it right there using what's called the hinge effect, right? You notice that this angle is 30 degrees. So let's redraw it. So always redraw these triangles just to kind of help you out a little bit. Angle C, that's going to be 30 degrees. This is going to be 30, and this is going to be 18. That's equal to little c, that's equal to little b. And so you can use the law of sines now. Where's the second triangle, you say? Here's the second triangle. So it's going to look something like this. And that's the second triangle that you're going to have to look at. Before we do that, let's look at the blue triangle first. So sine of c over little c is equal to sine of big B. There's big B, little b, over little b right there. And so we replace all the numbers. Sine of 30 over little c, which is 18, is equal to sine of b over little b, which is 30. I know the sine of 30 is 1/2, and I'm going to multiply it by 30 right there to get rid of that 30. 30 times 1/2 is going to be 15. Sine of b is equal to 15 over 18. Reduce that by 5, or I'm sorry, by 3. It's going to be 5 over 6. And I know that this is between -1 and 1, so I can use this. So the sine inverse of 5 divided by 6. And it's going to be 56.4 degrees. And there's your angle right there. 56.4 degrees. You can find this angle right now by using, what's it called? Angle sum has to equal 180. So if this is 30, this is 56, this should be some number. Okay? So that's your triangle that you have. How do you find the second triangle? This right here. To find this triangle, I'm going to redraw part of the bigger triangle. If this length is equal to that length, is because it's going to be the radius. Do you see that right here? The hinge effect creates a radius of a circle or an arc. So therefore, if this is 18, this is 18. If this angle is equal to that angle, then this is supplementary. So that's the key right there. 180 minus this angle B right there. Okay, and you have angle C. You should figure out what angle A prime is. And that's how you do that. The next question is the law of cosines. We did that, law of sines. The last one we're going to do is how to find the areas of triangle. The basic one is 1/2 times base times the height, right? Where the base and the height are perpendicular. Well, when you have an ASA situation, or actually you could have a SAS situation, actually, not ASA, then you're going to have something like this. Here's side 1, here's an angle, and here's side 2. You see how the angle is between the two sides? The area of an SAS situation is 1/2 times side 1 times side 2 times the sine of the angle between. And there's a second formula. There is a proof of that. It's not that difficult to prove out, but here's a shorthand version. If you're given an area of a triangle, given SSS, it's going to be square root of S minus A times S minus B times S minus C, where this is called Heron's formula, by the way. S is equal to the semi-perimeter. So if you have a triangle with A, B, C, S is equal to, the perimeter is A plus B plus C, right? That's the perimeter. And the semi-perimeter is divided by 2, half of the perimeter. So let's try an example. 5, 12, 13. So what's going on here? You take square root, the area of a triangle is equal to, let's figure out what s is. S is equal to 5 plus 12 plus 13. That's going to be 17 plus 13 is 30, divided by 2 is 15. That's the semi-perimeter. 15 minus 5 times 15 minus 12 times 15 minus 13. That's equal to square root of 15 times, that's 10 times 3 times 2. That's going to be 6 times 10 is, I'm sorry, 6 times 15. It's going to be 80, 800. No, is that right? 15 times 10 times 3 times 2. It's going to be 900, sorry. Right there. And the square root of 900 is 30. That's the area. I can check this work pretty well because if I have a triangle like this, I know it's a Pythagorean triple. Here's 5, here's 12, here's 13. 5 squared plus 12 squared equals 13 squared. It's going to be now 1/2 the base times the height. The base is 5, and the height would be 12. If the base is 12, the height would be 5. Same process because they're commutative. That's 1/2 times 5 times 12. Half of 12 is 6. 6 times 5 is 30. Whoop, there it is right there. You get the same answer no matter what. So you could have used 1/2 base times height. You could have used 1/2 side 1 times side 2 times the angle sine of the angle between. Or you could have used Heron's formula, which is right over there. Good luck with your homework. Thanks. Took a little bit over 10 minutes, 16 minutes or something. Bye.